I'm Aashita Sharma of 4CA25 and my roll number is 101803557.
My name is Ayush Jain and my roll number is 101815106 and I am of bench ENC5.
My name is Aniket Mendiratta. My roll number is 101815132 and I am a student of batch 4 ENC6.
Hello, my name is Priyesh Tiwary. My roll number is 101815103 and I am of ENC5.
Hi, I'm Saarthak Srivastava and I'm the team leader of Group 44. I'm from ENC5 and my roll number is 101815089. I'd like to take this opportunity to thank our mentors Dr. Neeru Jindal and Dr. Shubhra Jain for their constant support. Now Ayush will take over.
Good morning everybody. This is our project Handwritten Text Recognition using ML in caps in 2021 even semester. Motivation of the project. Handwritten recognition has been one of the most fascinating and challenging research areas in the field of image processing and pattern recognition in recent years. It contributes immensely to the advancement of automation process and improves the interface between man and machine in numerous applications. The development of handwritten recognition system begins in the 1950s when there were human operators whose job was to convert data from various documents into electronic format, making the process quite long and often affected by errors. There are basically three scopes of this project. First is healthcare and pharmaceuticals. The patient's prescription digitization is a major main point in healthcare pharmaceutical industry. Second one is insurance. A large insurance industry receives more than 20 million documents a day, and delay processing the claim can impact the companies terribly. Third one is banking. People write check on a regular basis, and check still plays a major role in most of the non-cash transactions.
Project is to recognize handwritten documents, which includes characters, words, lines, paragraphs, etc. Handwriting recognition contributes immensely to the advancement of automation process and improves the interface between man and machine in numerous applications. So basically in our approach, we will be implementing the offline handwriting recognition system using multidimensional recurrent neural network. Our goal was to design a handwriting to text converter by providing handwritten images as input using machine learning algorithms. So we read some research paper to get more ideas about our project. A study by Gaurav and Bhatia in 2013, which basically deals with the various pre-processing techniques involved in the character recognition with different kind of images ranges from simple handwritten form-based documents, Salvador, and many more like study by Palan Singh, Pradeep, Som and Saha. Existing tools and solution for this. First is Google Vision OCR, AWS Azure API Vision, OCR Space, PDF Element 6 and etc.
So here is a diagrammatic representation of the architecture of our model. So it begins with the input image being fed into the convolutional neural network layers, which are trained to extract relevant features from the image. Then the recurrent neural network propagates relevant information through a feature sequence containing 256 features per time step. The LSTM implementation of RNN is used so as to propagate information through longer distances and provide more robust training. The output matrix of RNN is then passed into the connectionist temporal classification layer along with the ground truth text to compute the loss value. So our model takes input images of single words or text line as input and outputs the recognized text, and the character error rate is around 10 to 15%. These are the various tools that we have used in the implementation of our project. Now I will like Saarthak to explain the working of the model.
Various Keras models like time distributed, activation, etc. have been imported for the functionalities. We have used pickle module, which saves the trained model so that we don't have to train for every instance. Then let's have a look at all the layers. 11 time distributed CNN layers and 3 bidirectional LSTM layers have been inserted. Optimizer is Atom, which has gradient descent. Batch normalization function has been used so that the results are not skewed towards a particular batch. Word beam search decoder is one of the main features of a model. Without this, the accuracy was around 65%, but it drastically increased to 85% when using this. It basically looks for words in a stored dictionary so that the correct words are recognized as seen in this example. Now the aforementioned dictionary is automatically created during training using words in IM dataset in the file corpus.txt. We can also add custom words, for example Thapar in word char text list. Now this is the result. We gave our model the input for work on line level, and as you can see here, like our model has correctly recognized it with an accuracy of 86%. Now this is how our Android app looks like. We have named it Text Recognition Android, and Android Studio and Gradle were used to build and run the app. Now let's have a demo. Okay, so here's the app. We're gonna take a picture of this. Engineering is the best. And then it'll take just a few seconds. And there it is. Engineering is the best. So now Priyesh will take over.
Prospective learning of this project. The first thing that we have learned are the team working skills. As we move into the corporate world, we will be required to work in teams with many different members to work on a project. All the members will have different abilities and we will be allocated different resources. So that will be the situation when all these team working skills will come in use. The second thing we learned was going through the technicalities of this project not only helped us in brushing up our technical skills and knowledge that we have learned in college, but the real world application of them, which is the unique learning point of such a project. And the third thing was that the study conducted in the field gives us significant knowledge in order to pursue the project for the future scope. We have learned some parts of it like Python and CNN model implementation in our college courses, while the other aspects like image processing using OpenCV and such softwares was something new to us, and it was very enriching for our future careers. Now coming on to the individual roles in team chart. So through all these Gantt charts of every individual member, we have shown their individual contributions in different aspects of the project, starting from idea finalization to testing and debugging. These are the individual charts, and the last one is the group team chart. So that was all for the video presentation. Thank you.